So let's look at some of these problems and relate them to our normal distribution. As we saw, and I'm going to look at this one down here because it has some nice, good space to work in. This one had a mean of 21, and the standard deviation was 10. So it went from, here is our mean. And then if we're within one standard deviation, we're going from 11 up to 31, okay, since our mean is 21. And what percentage of our data lies within that range?
68.
68%, okay. Now, one of the things I was hoping you guys would pick up on as you did the independent practice was that recognizing this as symmetrical, which we did talk about, when you are looking at just from the mean to that first standard deviation, in other words, from 21 to 31, what percent would be in that range?
34.
34, okay? Because it's symmetrical, we have half of the 68 here and half of the 68% here. Okay? We can do kind of a similar thing looking at the second standard deviation. Okay? From 1 up to 41. Okay? This entire range is what percent of our data? 95%. Okay? Which means on either side of our mean is how much?
47.
Yeah, 47.5. Okay, so from here to here is 47.5%. Okay. So if 34% is here, then we have 13.5% here, right? So these will add up to the 47.5. Likewise over here we have 13.5%. Okay? Then if we look at our third standard deviation, in this case it's from -9 up to +51. Using our approximation, we have 99.5% of our data, okay? If you notice, there's only a difference of 4.5% here, right? So that means how much would have to go in each of these little pieces?
2.25.
Yeah, 2.25%. Okay, 2.25% is going to go there. 2.25% is going to go there. And then that only leaves a 0.5% beyond 3 standard deviations. Okay, now that's obviously a really tiny amount, and that's why we don't really look at what's the percent of 4 standard deviations or 5, because it's such a tiny difference it's not worth trying to distinguish. So everything beyond is a 0.5%. So from 51 to positive infinity is what percentage?
2.5.
Yeah, 0.25%. And likewise over here, past -9 is 0.25%. Okay? Now, people are asking, do we have to memorize those or what? It's really up to you. If you just learn the 68, 95, 99.5, then you can learn it. Then you can figure this out. Or you could just memorize 34, 13.5, 2 1/4, and 1/4. And then it's going to be the same on the other side as well. However you choose to learn it or to remember it is up to you. Okay? But when we go to take a look at problems like this, first we need to draw our bell curve, okay? So the highest point in this example here says the mean height of players in a basketball competition is 184 centimeters. If the standard deviation is 5 centimeters, what percentage of them are likely to be in those different ranges? So the highest point is going to be what value?
184.
184. Okay? That's our mean. Then to sketch it, remember we're going to go up 3 standard deviations. So that's 184. This will be
189.
189 because our standard deviation is 5. Then we're at 194 and 199. Then we're going to go down 3 standard deviations. 1, 2, 3. So now we're subtracting 5. 179, 174, 169. Okay? And you can just do a rough sketch of your bell curve at this point. The key, though, are those values. And here's where it might be helpful for you to go ahead and write in your percentages. Okay? Remember I said if you just learn those 4 percentages, here's 34, 13 and a half, 2.25, and then 0.25. It's going to be the same on this side. All right, I'm not going to write them all in again. But once you have that, then getting the answers to each of those questions is really easy. Okay? What percent of them are likely over 189 centimeters tall? Well, now you're just adding 13 and a half, 2 1/4, and 1/4. Okay? You add those up, you get 16%. Right? Does everyone see how we found that?
You went 4 standard deviation.
No, it's not 4 standard deviations. This goes to infinity. This 0.25% just goes to infinity.
Oh.
That's everything to the right. Hey, what's another way I could find the solution to part A here, though?
I did it like, just like 50% and then minus the 34%.
Good. Okay. That's another way you could think through this one. If I want taller than 189, and I recognize that my mean is going to be at the 50% line, right? Everything to the right of my mean is 50%. Well, if I just subtract the part of that 50% I don't want, the 34, 50 minus 34 is 16%. Okay? Does that all make sense? All right. So now, what percent is going to be taller than 179 centimeters?
84.
84, okay. If you notice, this is kind of the complement of what we just did, right? Even though we were looking at above 189, this percent, that 16%, is going to be the same as the percent beyond 1 standard deviation to the left, right? So if this was 16%, this is 16%. Which means 100 minus 16, we have 84%. Okay, if that goes all the way to infinity. Okay? And again, there are a lot of different ways that you could think through this logically. We could also see it as Okay. We could also see it as, all right, taller than 179. I want the 50% to the right of my mean plus this 34%. Okay? And I'd get 84% that way as well. Okay? Are there any questions so far? Okay. Try figuring out C then. What percent would be between 174 and 199? Ready?
Is it 97.25?
97.25? Is that what you guys got?
7.5.
Okay. Yeah, 174 to 194 is what percent?
Oh, it's 95.
This to this is 95, right? And then we're just adding on this 2.25. Okay? So 95 plus 2.25, we got 97.25%. Okay?
So this is all just memorization, kind of.
It kind of is. The key is getting this set up correctly.
Yeah.
If you can sketch your normal curve, then it's really just, do you know your percentages, and then just picking the right regions. Okay? Alright. And then the percent over 199 centimeters. Yeah, it's just this little region right here. From that third standard deviation up above. Okay, so that's the 0.25. All right. So you've seen one done. How many of you were able to figure that much out on your own last night? Okay, a couple of you? All right. Let's try another one here, okay? Yeah, this will work. Okay. Let's try number 10. Take a few minutes, okay? Take a few minutes. Make sure you sketch your bell curve, okay? Put your mean down, go 3 standard deviations away from the mean, and write in those percentages, okay? Now, one thing I will ask before you get too far into this, Part A and Part B, what's the difference between what they're asking you to do in Part A and Part B?
Probability versus percentage.
They're asking you for a percentage in Part A, they're asking you for a probability in Part B. So what's the difference there?
How we express the values?
I'm sorry, what?
How we express the values?
Okay, yeah, the values themselves really aren't going to change. It's just how you're expressing them. The percentage of students or our probability of picking someone in that range is going to be the same idea. It's just a matter of how we're applying that idea. Okay? So, you're doing the same thing for Part A and B. Part C you have to think about a little bit, but I think you can do it. Alright, feel free to get help from a friend or consult with a friend. Alright, but go ahead and try number 10 here. Again, first thing you should be doing is sketching that curve. Yeah, because you can express a probability as a decimal or as a percent.
Website up there. That's our class website, and that basically has everything that you need on it. I'm recording right now. I record our lesson every day, so if you're ever absent, I record it and I upload it to YouTube, and I'll put a link on. It's just a blog, but I put any infinite practice that you have is on there. Quizzes or whatnot are on there, and then I can show you too at one point something here. I also have a textbook. You don't need to buy a hard copy unless you really want to, but it's a big book, it's heavy, so I have a PDF version of the textbook, and I actually have it in two books. One has the entire thing on one PDF, the other I kind of cut out chapter by chapter, so it's a little smaller file to load. In both cases though, at the end, they have the answers to odd number problems. And then, have you ever used Slater.com or CalChat? Okay. Slater, I have a link to it on there as well. It has a lot of the even number answers.
The first one,
with
second one,
worked out solutions. So if you get stuck and you can't get a hold of me or someone else, then that's one place you can go and try to find some. So, but,
Okay. So your bell curve should look something like that. The values along the bottom are really the most important. Okay? Making sure that you get those numbers right. So, between 162 and 170 would be what percentage?
34.
34. Okay, good. 34%. We're looking at this region right here. Okay, 34%. Good. How about between 170 and 186? Good, 47.5%. We're looking at this region here. Okay. Now for part B, the first one here, what's the probability we're between 178 and 186? Yeah, 0.135. You can still give your probabilities as a percentage, but okay. So 0.135. How about less than 162?
0.16.
Yeah. 16% is beyond that first standard deviation, so 0.16. Okay. How about less than 154? What is it? 0.025. Okay. 0.025. All right. If you remember, we had 34%. Okay. This is 13.5%. This was 2.25%. And this is 0.25%. Okay, so below 154 is 2 1/4 plus another quarter, so 2.5%. Okay, and then greater than 162 centimeters, 0.84. Good. 50 plus this 34 is 0.84. Okay. Again, everything above the mean is 50%, and then we want just that extra 34%, so we're up to 0.84. Okay? Alright, now for C. Okay? What is the value of some number k, and we're talking about a height. What's the height such that 16% of the students are taller than that height?
178.
Good, 178. 16% is above. It's from here to the right, okay? So that value is 178 centimeters, okay? All right, so any questions about doing this now? Does it make a lot more sense?
Yeah.
Okay. All right, so some of you were able to kind of figure it out a little bit more on your own, but now I think we all get it pretty well, okay? What's a natural question that you might have? You know, looking at what we're doing here, what's a question that might, maybe you don't have, but maybe someone might have about these kinds of situations?
Are the percentage ever going to change? Or is it going to...
Okay, that's a good question. Will these percentages ever change? The answer is, if we're talking about a normal distribution, no. Okay? There are a lot of things that, and it may seem like, okay, well then what's the point in learning this if it has to be a normal distribution? The reality is lots of things are normally distributed. There are a lot of things that are symmetrical, okay, in terms of, you know, things that are measured. For example, if we looked at heights of people, the majority of people are close to the mean height, all right, and then, of course, you have really, really short people and you have really, really tall people, okay, and there's about as many really short people as there are really tall people. Okay, you know, and you have the whole spread. If we looked at, you know, male students in a college, or if we looked at all the heights of the 16-year-old guys, or all the heights of the 16-year-old girls, we would get the majority close to the mean, and then you would see, obviously, some really tall and some really short people on both ends, okay? As I think through all the students I've had in 12 years, you know, most of them are around the same height, but I had one who was 16 and was, you know, 6'6". Now he's a senior in high school and he's 6'10". And I had some too I had a friend when I was in high school. He was a guy who was like maybe 5 foot. Okay. He was 5 foot on a good day, I think. But yeah, you have both ends there. But most of the guys, if you look at 16-year-old guys, you're looking somewhere around 5'8" to maybe 6 foot in that range. Okay. For an adult male, I think the average height is like between 6 foot and 6'2" or something like that. You look at other things like in manufacturing, what they'll have is a tolerance level. They'll have, for example, in a 2 liter of soda, if you look at them on the shelf, they're not all filled exactly the same. They say 2 liters on the bottle, but that's the average. Some of them are slightly more filled up and some are slightly less filled up. And they have a tolerance level, an acceptable range, and all of the fillings are normally distributed. Most of them are right there real close to 2 liters, but there are some that get filled way too much and some that get filled not nearly enough. So you have that normal distribution. Okay? Again, all kinds of stuff fall into this normal distribution. Even things like, you know, IQ or whatnot. You know, you have these super geniuses and you have people with mental disabilities who are really on the low end. You know, you have about an equal number. And then you have a lot of people falling into the middle ranges. You know, so again, that normal distribution, while it may seem like this doesn't really, well, it's just one case. It is just one case, but it's a case that happens a lot, okay? So, what's another question that you guys might consider here if you were looking at a situation like this? You know, we figured out the percentages that we figured out, but anything else come to mind?
Yeah. What's the difference between this and the Chebyshev's theorem?
Okay, good question. What's the difference between this and Chebyshev's theorem? Chebyshev's theorem didn't give us a specific percentage. It gave us at least this percent of the data will fall within the range. Okay? So that's one difference. Chebyshev's theorem said that at least, what was it? It was at least 75% of the data would fall within 2 standard deviations. Right? There's 1 minus 1 over 2 squared. So 0.75. Well, here in the normal distribution, 95% of our data falls within 2 standard deviations. So is Chebyshev's theorem true still? Yeah. Okay. The difference is, for Chebyshev's theorem, that worked no matter what the distribution was. Okay? So it did not have to be distributed normally. We could have any kind of crazy distribution, and it would still fall into that range. If we were within 2 standard deviations of the mean, we'd have at least 75% of our data. Okay? So that's kind of the difference. This gives us more precise values, but Chebyshev's theorem works no matter what the distribution. Okay? What if I asked you, what percent of these students are at least 174 centimeters tall? Okay. 174 is kind of in the middle of that, right? It's not going to be exactly, you know, this is not linear here. This is a curve, so we can't just cut it in half and get 17, although that wouldn't be a bad approximation. Okay? The fact of the matter is that without a better tool at our disposal, we really can't tell what percent. would be taller than 174. Okay? That's where our technology comes in handy. All right? Our calculators actually have a good tool in order to be able, or are a good tool to be able to find values that are not within this exact, okay, we're 1 standard deviation or 2 standard deviations away. Okay? Now let's take a look at that. This is the actual new stuff that I want to look at today. But it's actually it's really short, but it's really powerful. Okay? It'll actually show me what's on the slide. Okay. All right. Now, yesterday I showed you this function. I said don't bother writing it down. Okay. Still, don't bother writing it down. But every bell curve that we've sketched, or every normal curve that we've sketched, we could get by using this function right here. It's what's known as a Gaussian function. Okay. Carl Friedrich Gauss, mathematician, did a lot of work with this, so they call it a Gaussian function. All right. But here we have our normal curve. And in this case, the mean would have been 0. Okay. The standard deviation actually ends up being 1 for this specific one. But remember what I said, that the percent or that probability represented the area underneath the curve. Okay? So, for example, if I'm looking at from my mean up to positive infinity, you know that that's 50%. Okay? The area underneath this curve is 0.5. Okay? Now, one thing that you'll learn in the future if you go on to study any kind of calculus is that area under a curve is actually given by an integral. Okay? Now, we're not going to learn how to do integrals right now, but I want you to understand what your calculator is doing when we use the function we're about to use. Okay? Your calculator will actually be giving you the integral of this nasty function. Okay? So, how do we get it to do that for us? Right? Well, here's the name of the function that we're going to work with. It's called normal CDF. All right? So, if you haven't already, please get out your graphing calculators. If you do not have yours with you today, you need to move to where you can see one. Okay? And if you typically have an N-spire that you work with, get next to someone who has an N-spire, please. If you typically have an 84, get next to someone with an 84, okay? If you need to move your desk, okay? But move to where you can see, okay? Do you guys have one? Do any of you guys have one? All right, so rather than 3 of you looking over her shoulder, okay, bud? Why don't you look next to you there, okay? Hunter, do you have one? No. Why don't you look on with Alexi so you can see? All right, or do you have an N-spire? Do you have an N-spire? No. You don't have a, do you have a graphing calculator? You don't own one? Okay, you need to get one. It's required for this class. Okay? Get either a TI-84 or a TI-N-spire. Okay, one of those two will be best for this class. Okay, but for right now, why don't you scooch over and watch with him, okay?
Alright, I don't know what I'm doing, so.
Alright, so where do we find this? Okay? If you have the TI-84 or the 83, it's the same thing, okay? Oh. you'll notice the button with VARS on it. It's up near the arrow keys. Okay? You're going to hit second VARS because that is, it says DISTR. That's for distributions. Okay? That's where the functions related to different distributions are. Okay? So I'm going to hit second distribution. Come on. There we go. And now notice, be careful here because there are two. One says normal PDF, the other is normal CDF. The normal PDF is what you would use if you wanted to actually graph and see the bell curve. Okay? We're not going to do that. The normal CDF, it stands for normal cumulative distribution function. Okay? In other words, it's going to give you the percentage of the data with a certain mean and a certain standard deviation that lies within a range of values that you give it. Okay? So, I'm going to use normal CDF number 2, and let's actually go back to the example that we were just looking at. Okay, where'd it go? Oh, over here. We saw that the mean was 170, the standard deviation was 8, and let's just do this first one right here. We want it, what percent is between 162 centimeters and 170 centimeters. So we're going to type in our range first of all. We put the lower end in first, 162, and then a comma. It's right above the 7 key. Okay? Those of you with an end spire, I'll get to you in just a sec. But this part is actually going to be the same. Alright? Then I put in the upper bound, 170. Okay? And then another comma. Then I type in my mean. The mean is 170. And then another comma, and the standard deviation is 8. And we close our parentheses, and we hit enter, and we get 34.134 and so on percent. Okay, so you notice our 34% was an approximation, okay? But this is the precise value. Okay, did everyone get that to work for them? Okay, now guys with the end spire, you have two options. One, you'll see the little button that has like an open book on it. On the right hand side of your keypad.
Got that.
Okay, did you find that, Elon?
Wait, why would you use that?
Go into your.
So this is the,
You're.
What
Which one you're.
okay, so in this case we're doing
Yeah.
between 162, right? And 170, right?
So I just kind of like.
And then we have the mean and the standard deviation.
I guess I'll do it.
And then this is the percentage that it was. So it's
Okay.
the big
So
number.
go to the, if you click on the book, you can scroll down, or like if you go to,
So he said like
if you just type in
the number is not you.
if you type in an N,
It's 172.
CDF.
Yeah,
And then we can go like
we can go like that. And same thing, yeah. So if you want to try it too, you just
Okay, so yours is called norm CDF. Okay, Elon, did you find it? Okay. Alright, let's see. Go back here. If you do just the basic calculator. Okay. And then hit the little, see the little open book. You can type in
like the number
to get down to what ends are. And then you want
Oh, I mean like how do I know which numbers to plug in?
Now, hey guys, with the Nspire, the other option, if you don't like scrolling through the catalog, you can just type in norm CDF and hit parentheses, and it'll recognize the function. That may be easier. But for you guys on the 83 and 84, it's called normal CDF. Nspire just calls it norm CDF. But, no. But, did everybody get that to work? Okay? The only thing that's a little bit tricky is when you have these ranges like less than 162. If I wanted less than 162, I would put 162 as my upper bound. What could I put in from the lower bound? If I wanted to go to like negative infinity,
-1 each.
yeah, I could just put in like negative 99999, or I could put, in this case, I could put 0, because that's going to be like, if you have a standard deviation of 8, that's like 20 standard deviations below my mean. So I could punch in 0, or I could punch in negative 99 or something like that. But notice there it should have been 16, or we approximated 16%. It's 15.86%. Alright, so really useful function that we can use to find percentages that don't fall right on the standard deviations. Okay? We'll work on practice problems with this on Thursday. We'll also start reviewing some for your test a week from today. Okay? So, I think we're it with the time. Yeah, the bells aren't on. So, have a great day, guys.